This is exercise 408, multiple displays. We're just looking at question 5 here. So this population pyramid shows the number of Indigenous persons in Australia in 2006. Okay, I think some people have already answered part A, question A, parts 1, 2 and 2. Females 55 to 59. If this is 5,000 there and that's 10,000, this line here is definitely closer to 5,000 than it is to 10,000. So I'd go the 7,000. You should really get a ruler and just see how many millimeters from 5,000 to 10,000 on this scale. Number of people in 15 to 19 age group, you've got to add the females and the males. So the males is 25,000 and over here the females. That looks like it's about 24,000, okay? And then that's 49,000. In which age group were there about 5,000 females? Which one are you going to go for? In which age group were there about 5,000 females, isn't it? 60 to 64. Suggest a reason why there are more people in the over 65 age group than in the 60 to 64 age group. Yes, the reason for that is each age group only does 5 years. 50, 51, 52, 53, 54, 5 years. But this 65 years and over could be 65 to 69, 70 to 74, 75 to 79. Yes, it's because the over 65 age group is really 65 through to death. It's not only 5 years. It is not only 5 years. So it's not only 5 years, it takes in a bigger range of ages. Careful with the shape, because this one, the shape of the distribution, the males is, what would you call that? It's positively skewed. But the females, you can't read it that way. Okay, you can't say that this is also positively skewed, even though it looks weird. It's because, you know how the axis is backwards? Can you see the axis here is backwards for the females? Since when do we do 0 to 4, 5 to 9? See how the axis is backwards? So it looks negatively, but it's not. It's positively because most of the data is at the beginning. When most of the data is at the beginning, that's positively skewed. So they're both positively skewed. Okay, so both distributions are positively skewed, so both are positively skewed. Actually, I'll put it down here. Both distributions are positively skewed. Be careful with the females because the scale is backwards. Do you see that? So are positively skewed. What does that mean? If they're both positively skewed, this is, in other words, there's a lot of younger people, isn't there, in both populations? All right, but the male ones seem to, are there more, there are more females than males, you know, by the looks of things. There are more females than males. Yes. There are about the same number of Indigenous males as females. You'd have to have a little approximation. Just looking at the males, the first one's about 27. I'm just putting the whole numbers. The second one is almost 30. It's like 29,500, really. Same with the third one. You know, these two are almost 30. I'm just going to go approximately 30,000, approximately 30, approximately 25, approximately, I think that's about 18. But these are both 15 and 15. And the next one I'd say 14 and 12 and 11. Sorry, 14, 12, 11. So has anyone else done it for the other side? 8 and 6 and 4 and 7. That's what I've got for males. I know that's a bit time consuming. If anyone, and females? Yes, someone did say, yes. See, someone said that the scale is different. Like there's only 8 millimeters here, there's 10 millimeters there. It's because they've gone up to 35,000 here. Sorry. They've gone up to 35,000 here, but only 30,000 there. So visually, it's a bit hard to tell. You'd have to look at the, look, I don't think in the HC that asked something that involved this much work. All right. Then we can look at the females. 222,000, 225,000, and I may be off a little bit. But, you know, what you could do is just compare each. Look, 27,000, this one's about 27, 28. This one's about 28, this is about 29. Do you know what I mean? They're fairly similar, all right? And that would have been enough just to do that, all right? So, yes, they're about the same. Yes, about the same. All right. Now, going back, just this one here, the HSC question, 2011 question 25B, just reading the columns correctly, the white column is the number of students in the year group, and the coloured column is the number of students who own a mobile phone. And it says which year group has the highest percentage of students with a mobile phone. It would be where the two columns are closest. Well, it's last one, it's year 12. What percentage? 100%. 100% of the kids have a mobile phone, because there are 50 kids and 50 have a mobile phone. 2 students are chosen at random, one from year 9 and one from year 10. Which student is more likely to own the mobile phone? You'd have to do the percentages for each year group as well. So year 10 is, isn't it 50 out of 60 times 100? And year 9 is 55 out of 70 times 100%. Okay? So whatever you get for those, anyone got answers? Justify your answer with suitable calculations. Means you don't just give us the answer. You have to do the percentages for both. What often works is you get a mark for the calculations, and then you get a mark if you've justified your answer using the calculations. So, okay, so what have we got for year 10? What percentage? What percentage? 83.3 recurring, isn't it? 83.3 recurring percent. And the other one is 70, approximately 78%. So therefore, you know, when you do probability, you can give your answer as a decimal, you can give your answer as a percentage, or you can give your answer as a fraction. I wouldn't, in this case, give it as a fraction because the denominators are not the same. You can't compare two fractions with different denominators. So you'll convert them to percentages, or just divide 50 by 60 and give it as a decimal, because probabilities range from 0 to 1 or 0 to 100%. So your answer therefore is year 10, and we've justified it there below. And identify a trend in the graph. What do you think? The older, the higher the age of the year group, what? The more likely a student will own a mobile phone. So the higher, as the age group, the greater percentage of students that own a mobile phone. The greater percentage of students that own a mobile. Okay, that's what you would say. So the higher the age or year group, age/year group, the greater percentage of students that own the mobile phone. Okay. And I know we're working backwards in this one. Yesterday, we had a quick look at question 1. All good? And you've got to be really careful, because this is a frequency graph, but it means that 2 year 12 classes were given a sports quiz and the student scores were shown here. If you want to know, so a mark of 5, 2 people got a mark of 5. So if I added up their scores, 2 people got a mark of 5. So this is what this really means. I've got 2 5s, let's say I do the first test, 12p. This is really what I've got. I've got 2 people that got a 5, 6, 3 people got a 6, etc. Do you get what I'm saying? 2 people got 7 in that class. Let me add up all the sum of the scores for 12p. What does this? 2 people got 5. Don't theirs add up to 10 for 12p? 3 people got 6. Their marks add up to 18. 2 people got 7. Their marks add up to 14. 8 people got 6. Their marks add up to 48. 7 people got 9. Their marks add up to 63. So there are some questions here asking about the mean and the skewness of the data. We're going to have to work out the mean first. So let's work out the mean of 12p, of class 12p. You'd have to add up all these numbers on top of the columns for 12p. So 10 and 18, that's 28, 42, 90, 153. Remember, your mean is your sum of scores over the number of scores. How many people were in that class? Look here how I've written out the data. I had 2 people, 3 people. Do you get it? So 12p, the number of students, was 2 plus 3 plus 2 plus 6 plus 7. That's 20, isn't it? Yeah, over 20. So the mean, remember, is the sum of the scores over the number of scores. That average is 7 point something. What do we get? 7.65? I think so, yeah. And for class 12Q, you have to do the same thing with class 12Q. We have to see how many kids there are. There's 2 and 5 is 7. So 12Q has, I'm just going to add them up in my head. 2 and 5 is 7. 7 and 7 is 14. Don't worry. 2, 5, and 7. What else? 4 and 2. And we've got 7 and 7 is 14. 14 and 6. It's also 20 kids. Would have been nice if they told us there were 20 in each class. So the sum of their scores, we've got to do the same thing on top of each column. I'm going to do it in a different colour. 5 times 2 is 10. 6 times 5 is 30. 7 times 7 is 49, 8 times 4 is 32, and 9 times 2 is 18. And has someone added those all up? The blue ones? 41, 39, over 20. You know what? The other thing is, instead of working it out, isn't there an easier way? Just below 7, 6.9 something. Yeah. Instead of doing that, do you think the 12p columns look bigger overall or not really? Well, it's a bit hard to tell. No, 12Q is bigger here, but 12P is bigger there. So, do you know what I mean? And then, because these are bigger, but these are higher scores, you probably have to work it out to be sure, because it's very close. You can't tell, because even though you've got higher columns for scores 6 and 7, they're lower numbers. And when you multiply it by how many people there are, remember, average or mean is sum of all the scores. It's really hard to tell what the sum of the scores is going to be. Because, yes, more people got a higher mark in 12p, but more people got this mark here in 12Q. You could take a guess. If you were rushed for time, you'd say more people in 12p got higher marks. Do you know what I mean? But in 12Q, a lot of the, fair few people got marks in the middle. I think 12p's average is going to be higher. Do you see that? More people got good marks in 12p. But in 12Q, these middle columns, the darker ones, more people got 6 and 7. Whereas in 12p, more people got 8 and 9. So we're thinking 12p's average will be higher, this first class. And it does. It is higher, but just slightly. It's not hugely, right? So what have we got? Who's got the higher mean? 12p. So 12p's scores, what have we got? Or 12q's got the lower mean. Now, let's just look at their scores. We've got 2, 3 for 12p. 2, 3. This 12p looks negatively skewed. Let's look at 12q. We've got 2, 5, 7, 4, 2. It is almost symmetrical, 12q. It could be 2, 5, 7, 5, 2 is perfectly symmetrical, but 2, 5, 7, 4, 2 is almost symmetrical except for one kid. Really? So I'd say 12Q scores are symmetrical. Look, they're definitely not positively or negatively skewed. And 12Q does have the lower mean than 12P. Okay? Sorry, we did that one back to front, multiple displays. Okay? And we pretty much just looked at clustered column graphs. And we did the population pyramid on the page before.